Okay, this is Unit 3, Lesson 3, solving multi-step equations. Before we get started, I'd just like to say sorry about my voice. I've got a cold while making this video, but we'll just have to get used to it. Alright, so our objectives today, two of them. One is to solve multi-step equations, and the other is to write proofs. We've talked about proofs before and how you're going to use those all the time in Algebra 2 and Geometry and all that, so we're going to introduce you to those a little bit today. Alright, let's get started. Okay, so here's two examples of multi-step equations, and I've got your steps on the right side to solving multi-step equations. The first step is to change any subtraction to addition. Okay? That's if necessary. If it's subtraction, change it to adding first. Step 2 is to distribute if necessary. Okay, so look for those parentheses and see if you have to do that. And step 3 is to combine like terms. If you have like terms after distributing or whatever else, combine them. You're going to isolate the variable term. The variable term is like 3x or 2x or negative 1x, whatever it is. Get the term with the variable by itself. Then step 5 is to isolate the variable. Get the variable itself alone. Okay, so get x and whatever it is by itself. Alright, so let's look at the first example here. First thing we need to do is change subtraction to addition. So step 1, 4x stays the same. Change the minus to a plus. So the 3 goes to the opposite, to negative 3, times x. Minus sign changes to a plus, so we go to the opposite of 2, that's negative 2, equals 21. Okay, so we changed all subtraction to addition. Now, it says distribute if necessary. Okay, it is necessary to distribute here because we have those parentheses. Well, the 4x isn't a part of any of that, so we leave it. Keep the plus sign. Now we got to distribute. Negative 3 times x is negative 3x. Keep the plus sign. Negative 3 times negative 2 is positive 6. It equals 21. Okay, next is to combine like terms. Well, I've got two x's over here. I can combine those. 4x plus negative 3x is just 1x. Plus 6 equals 21. Okay? Isolate the variable term. So I got to get the variable term by itself. That also means that if like I had a 2 in front of the x, I would need to get 2x by itself. But here it's only 1x. So I isolate that by undoing what I have done to it. So I've added 6 to my variable, so I need to undo that. So I need to do a negative 6 to both sides. And these things cancel, and I get x equals 15. Alright, let's go to another example here. So example 2, change any subtraction to addition. I've got no subtraction. This doesn't count as subtraction because I'm not taking anything away from it. Okay, so we're going to leave it alone. So, now that I circled that on x, I'm going to rewrite the problem here. 66 equals negative 6 over 5 times x plus 3. Now I do need to distribute. Well, the 66 and the equal sign aren't parts of that. So negative 6 over 5 times x, that's negative 6/5 x, plus negative 6 over 5 times 3. We'll do that over here. Negative 6 over 5 times 3 over 1. That gives me negative 6 times 3 is 18, and 5 over 1 is 5. Okay, so negative 18 over 5. Now, there's a little trick you can do here. I could isolate my variable term by getting rid of this negative 18/5 and putting that over on the other side. But a lot of us don't like to work with fractions. So there's a way to work around the fractions as well. Okay? If these have a common denominator, you can multiply the entire equation by this common denominator to get rid of it. Okay? So what I mean by that is, let's say that this was a 3 and this was a 2. I could multiply the whole equation by a common denominator, 6, okay, to get rid of my fractions. Well, these are already in common, so I could multiply this whole equation by 5. Okay? But what that means is I have to multiply every single part by 5 to be able to do that. Okay? Well, let's start with the easy side over there. Negative 6/5 times 5 that just gets rid of the bottom part. So it becomes negative 6x all of a sudden. Plus negative 18 over 5. If I multiply it by 5, that just gets rid of the bottom part. So now it's negative 18. So now I got to do 66 times 5. Okay, and actually first I want to show you again why that is, because some of us aren't very good with fractions. So maybe if this will let me here. Let's get rid of this. Oh no. Crap. Okay, sorry about that. Okay, let's get rid of... Oh no, I don't want to get rid of all that. Okay, anyway, let me show you real quick. Sorry about all that confusion there. I was trying to figure out this iPad thing. Let me show you quick why we could just get rid of the bottom number if I multiply by that denominator. Okay, think about it here. Negative 6 over 5. If I multiplied that by 5 over 1, we would cross simplify here and get rid of those. So we get negative 6 over 1. So that's where this comes from. That's why if we multiply by the denominator, we're able to just basically get rid of the bottom number. Alright? So now, let's move this up a little bit. Let's go ahead and take our 66 and multiply it by 5, because we have to multiply by everything by 5 to get rid of those bottom numbers. 6 times 5 is 30, carry the 3. 6 times 5 is 30, plus 3 is 33. Okay? So again, multiply everything by the denominator, you can do that if you don't want to deal with the fractions. Now I isolate the variable term. My variable term is negative 6x. So to isolate, I get rid of what's on the same side. So I have to do the opposite of negative 18, which is positive 18 to both sides. Okay, well these cancel, so I get negative 6 times x. And this is 348. Now I've got to get the variable by itself. So to do that, I'm going to divide by negative 6 on both sides. And these cancel. And I get x. And a positive divided by negative is a negative. And 348 divided by 6 is 58. Okay, so negative 58 equals x. You know I like you to turn those things around. Okay, so x equals negative 58. Alright, so that's multi-step equations. Let's do one more example of those. Okay, so we got 3 plus 3x over 4 equals 15. There's no subtraction to change. There's no distributive. So let's get the variable term by itself. The variable term is the 3x over 4. Okay? Now, in the last example, we showed you that if you have a denominator, you can multiply the whole equation by that denominator to get rid of it. So we can do that first right away, actually. My denominator is 4. Means there's no other fractions. Then my common denominator is 4. So if I multiply everything by that 4, 4 times 3 is 12, plus, that just gets rid of the denominator for that fraction, and 15 times 4 is 60. Okay, now let's isolate the variable term. The variable term is 3x, so I'm going to get rid of the 12 on both sides. And 3x equals 48. And then I'm going to divide by 3. And 48 divided by 3 is 16. So again, this is another example where being able to multiply the whole equation by a common denominator is pretty nice sometimes, because you don't have to deal with any fractions. Alright, let's go on to the last example. Okay, let's talk proofs. You are going to hate these, but I don't care, because you're going to have to know them when you get to high school anyway. So a proof is an explanation of what you did and why you were able to do it. Okay, so when you do the proofs, if I were you, you know that sheet I had you fill out of all the different properties and stuff like that? Use that. Okay, use those properties, because that's going to help you to be able to explain what you did. Because those properties are reasons why you can do things. So, proof. Let's talk about it. Okay, first thing you're going to want to do every time is rewrite the example. So even though it's typed out here nice, I'm going to rewrite it. So 2x minus 3 times 4x minus 5 equals 5. Okay? And our proof for being able to rewrite it is called given. Okay? That's what they gave to us. So that is the given. Next thing that you've been told to do is to change any subtraction to addition. Okay? So 2x stays the same. We get plus negative 3 times 4x plus negative 5 equals 5. Proof for that is that we are able to change subtraction to addition. Okay, so again, that's telling me what you did and why you're able to do it. Okay, we are able to change subtraction to addition, so that's the proof for it. Next thing you were told to do is distribute. Okay, so we're going to distribute this. The 2x and the plus sign are not involved. Negative 3 times 4x is negative 12x. Plus negative 3 times negative 5 is positive 15 equals 5. Proof for that is distribute. That's what we did. Okay? You could also write distributed property. Would be another way to write that. Okay, the next thing you're supposed to do is combine like terms. So 2x and negative 12x, those go together. 2 plus negative 12 is negative 10 x's. There's no other like terms. So my proof is combine like terms. Alright. Well, let's keep going here. Now we've got to get the variable term all by itself. Okay, so we've got to put a negative 15 on both sides. These cancel, gives me a negative 10x equals negative 10. Oops, let me rewrite that a little better. Okay. Now, I know we had an addition property and a multiplication property of equality where we said we could add or multiply both things, or both sides of the equation by the same thing. Well, there's also a subtraction property of equality. So that's the property that states that we can subtract the same thing from both sides. Okay, subtraction property of equality. And there's also a division property of equality if we need to divide on both sides. Which, coincidentally, the last thing we need to do is divide by negative 10 on both sides. Okay, and we get x equals negative 10 divided by negative 10 is 1. And the property that states that we can do that is the division property of equality. Okay, so those are proofs. Alright. Now on your assignment, you're not going to have to do proofs on every single problem, okay? But you will have to do them on some. We're not going to pick a whole bunch, but Miss Cookton and I are going to pick a few problems that you will need to do some proofs on, okay? So we'll explain that to you on the assignment. Otherwise, happy homeworking.